everyone. Thank you for joining us today for our HashiCorp Solutions Engineering Hangout hosted by Roger Berland. So today we're going to talk about Terraform, HashiCorp's Terraform Cloud. Terraform Cloud is an application that helps teams use Terraform together. So it manages Terraform runs in a consistent and reliable environment and includes easy to access for shared state and secret data, access controls for approving changes to infrastructure, a private registry for sharing Terraform modules, detailed policy controls for governing the contents of Terraform configurations, and more. So over the past few months, HashiCorp has released two significant enhancements to Sentinel in Terraform Cloud. So during this SE Hangout, Roger will explore some policies that use the v2 imports and reusable functions. So I want to note that the Hangout is being recorded and will be made available after post-processing, which usually takes 2 or 3 days. So I will email it out to all of you if you register for the event. The presentation and demo will be about 25 to 30 minutes, and then we'll allow 30 minutes afterwards for Q&A. So please, throughout the whole presentations and demos, submit your questions through the Q&A portal, and we'll get to those at the end. So with that, let's go ahead and get started. Take it away, Roger.
Okay, thanks so much, Brianna. I think we have about 30 people right now. Hopefully maybe we'll get a few more joining as we go. For now, I'll just, let's see, I'm adjusting a few things on Zoom, sorry. Okay, so I mean, people who join late won't miss too much because I'm gonna start out by level setting a little bit about Sentinel and how it fits into Terraform. And I think a lot of people likely to attend a session like this may already know about that stuff. But I do like to level set just in case. So again, my name is Roger Berland. I'm a technology specialist here at HashiCorp. I've been at HashiCorp for getting close to 3 years, maybe 2 3/4. And I've been a solutions engineer and now a technology specialist focused on Sentinel across all of our products and also on Nomad and Terraform to a degree. In fact, I used to say Terraform was my main specialty, but then I've kind of, moved on to these other things. So, okay, let's try to advance the slides. So this is the agenda for today. I'm going to level set, as I said, talking about Sentinel and how it fits into Terraform Cloud and Terraform Enterprise. Just to clarify, by the way, and you'll see this in our documentation, but Terraform Cloud has 2 different meanings. It's actually an application by which we implement, our commercial versions of Terraform, but it can refer to the actual application. But then it can also refer to, our own hosted implementation of that. So we'll talk about Terraform Cloud as something you subscribe to, and we run that at a URL, app.terraform.io. But then Terraform Enterprise, which is basically that's the self-hosted implementation of Terraform Cloud that customers can run, either in their own data center or in their own Amazon, AWS, VPC, or in Google or Azure or other clouds. Terraform Enterprise uses the Terraform Cloud application. So a lot of anything I say about Terraform Cloud, if you are already using Terraform Enterprise, I want to assure you that that does apply to Terraform Enterprise as well. There are sometimes a delay up to about a month, sometimes for brand new features. Both of these new features here that I'll talk about, the new Sentinel features, they are already available in Terraform Enterprise, the most recent version. So what I'll do is I'll cover those features. I'll then talk about the evolution of Sentinel policies over the last 2+ years. I'll show you some prototypical 3rd generation Sentinel policies and discuss some common functions. I've written a bunch of common functions, essentially a library of common functions that make writing these Sentinel policies easier. And especially it's easier for people who may themselves not be developers and may not be used to writing code that has the typical programming constructs of, for loops and if-else conditionals and things like that. I've tried to make it possible. I think about 90% of the policies can actually be written simply by calling the functions that I've written in various ways. So we'll get into that later. I will then discuss how you can test and use these 3rd generation Sentinel policies, which are all available in a repository that I'll show you, a GitHub repository, and then I'll give you a demo. Okay, so first of all, Sentinel in Terraform Cloud and Terraform Enterprise. What is Sentinel? Sentinel is a framework for implementing governance policies as code in the same way that Terraform implements infrastructure as code. It includes its own language, and it's embedded in HashiCorp's enterprise products. Using Sentinel ensures that your governance policies are actually being checked rather than just being listed in a spreadsheet. In other words, the Sentinel policy checks are in the flow, in the pipeline, we could say, for how Terraform infrastructure or configurations are being planned and then applied. And we'll see that in a few slides. Sentinel supports fine-grained policies that use conditional logic, but as I said in the first slide, by using functions, we can avoid having to deal with some of that logical stuff and make it easier for people, to use. It does also include a CLI, which used to be called a Sentinel simulator, but now it's called the Sentinel CLI, command line interface, that allows you to test and run policies. And that actually is really important because it significantly speeds up the development of new policies and the testing of them. Okay, so Terraform Cloud and Terraform Enterprise have a number of features that Brianna mentioned before, user interface, workspace management, team management, state management, secure variable management, being able to declare variables, marking them as sensitive, and then making sure that nobody else can read them. Remote runs and state, so in other words, we're storing the state for you on the Terraform Cloud or Terraform Enterprise servers. Integration with VCS systems so that your Terraform code can sit in a GitHub or a Bitbucket or a GitLab repository, and then that gets imported, or when you make updates to that, when you do pull requests and merges, that automatically kicks off a run within TFC or TFE. A number of other things as well: private module registry, configuration editor, Sentinel, of course, which is what I'm focusing on, single sign-on via SAML integration, and audit logging. So, and Terraform Enterprise servers can be deployed to self-host Terraform Cloud in your own VPNs or data centers, as I mentioned before. So where is Sentinel used in Terraform? Sentinel policies are checked between the standard plan and apply steps of Terraform runs. Now, policies can have different enforcement levels. They can be advisory, soft mandatory, or hard mandatory. Violations of these policies prevent runs from being applied unless a user with sufficient authority overrides them. Now, advisory policies that are marked advisory, it doesn't matter. They don't need to be overridden. That's just advisory. Soft mandatory policies do need to be overridden by somebody with the sufficient authority. Those people would be either members of the owner's team of the organization or members of a team that have a permission called managed policies. And then you have the hard mandatory policies cannot be overridden by anybody, right? That's the distinction between soft and hard mandatory. Now, Sentinel policies can evaluate the attributes, by which I mean both arguments and exported attributes of existing and new resources and data sources. And it does that based on information from the current run. And that includes the plan, the configuration, the current state, and other run data, including some workspace and organization metadata, as well as metadata from the run and cost estimates. Cost estimates is one of the features of Terraform Cloud and Enterprise as well. So the bottom line here is that using Sentinel in TFC or TFE ensures that your resources do comply with all your policies before they're provisioned. So this is how Terraform works without Sentinel. Generally, you're going to have your Terraform code sitting in a VCS repository. You're going to either, if you've integrated your workspaces directly into those repositories, a run is going to be kicked off either because somebody did a pull request or a merge, or because you use the UI to trigger the run. It's also possible to trigger runs with the Terraform API, Terraform Cloud API, and also through the CLI with the remote backend. Now, you might also do this through a pipeline. So for instance, if you were using Jenkins, then you might have Jenkins pull down the Terraform code from your repository, and then Jenkins might use the TFC API to actually trigger a run against the workspace. So normally what would happen though is you would just, after that, you would have the plan and the apply would actually provision the infrastructure as specified in your Terraform code, your Terraform configuration. Now with Sentinel, you then have the policy checks sitting between the plan and the apply. And as I said before, unless all the policies pass, or they either all have to be passed, or the soft mandatory ones can be overridden by the appropriate people. Only if that happens can you then do the apply. Now, by the way, if cost estimates are enabled, they're going to run right after the plan. And we'll see that in the next slide. Excuse me one second. So, so this is what it looks like. This is a run after it's totally finished in the Terraform, Cloud UI. We see that a plan was finished, cost estimates were done, policy checks all passed, and then the apply was done, right? And I did that. We see the user who did all these things. It was me. Now, how are customers using Sentinel and Terraform? This slide basically talks about a few of the use cases for Sentinel in Terraform Cloud and Enterprise. So fundamentally, the first 3 bullets are about enforcing security standards, doing things like requiring that all S3 buckets use the private ACL and can be encrypted by KMS, or, for example, restricting which roles the AWS provider can assume if you're using the assume role stanza of the AWS provider. Blacklisting or whitelisting resources, data sources, providers, and provisioners. So those are some of the examples, by no means all. Also, avoiding excessive costs, limiting the sizes of virtual machines and Kubernetes clusters in public clouds. Obviously, if you're using smaller VMs or a smaller cluster, that saves money, but you could also potentially save costs in other ways. And you could do this actually using the actual cost estimates, right? I have some policies that limit the monthly spend of a Terraform workspace. And you could do that actually with different limits for different workspaces based on the name of the workspace. So dev workspaces maybe could have $200 a month, QA could maybe be $500, production could be $1,000, just as an example. Now, there are some other use cases at the bottom here, things like enforcing mandatory tags on resources provisioned by Terraform, and that can be done across all the clouds. Mandating that all modules come from the private module registry, and then maybe in addition to that, not allowing resources to be created in the root module, right? Because if you have a lot more control over the modules that are in your private module registry, within your TFE or your TFC server, right? So if you know that all modules, every Terraform configuration has a root module, and that root module can then call other modules, right? So if you know that all the other modules come from the private module registry and you don't allow resources to be created in the root module, well, then you have pretty good coverage in place, right? You can be pretty assured that things are not being done that you don't want. Finally, the last example here is enforcing specific Terraform coding conventions, making sure, for instance, that variables have descriptions or things like that. So let me move on now and talk about these 2 new Sentinel features. And I'm sorry that my voice is kind of scratchy today. I'm not sure what's going on. Well, I do know, but I'm not gonna. I've just had something going on for a while here. Not actually sick; it's just something else. So Sentinel modules is the first new thing. A Sentinel module defines Sentinel functions and rules in a file that can be used by Sentinel policies with a single import statement. And this is important because it avoids the need to paste the functions into every policy that calls them. It used to be, and we'll see this when I talk about the evolution of the policies, that up until the new 3rd generation policies, if you were using functions, even if you wanted a function to be used in 10, let's say in 10 different policies, you had to paste it into all 10 policies. And if you needed to change it, you needed to change it in all 10. And that was obviously not good reusability, and it was a nuisance and time consuming as well. So Sentinel modules are registered in the Sentinel CLI configuration files and in your TFC or TFE policy set configuration files. And they can actually, the modules can be in a local repository where those policy set configuration files live, or they could actually, you can use a URL. You could point to a different repository, and that would be done using a raw URL. Like in GitHub, for instance, not the standard URL that points to the HTML page, but the actual raw URL. The Terraform guides repository, which is where I have all these 3rd generation policies and functions, does include 5 different 3rd generation modules, the ones that are named here, and they're all very well documented. And we'll be making these slides available, by the way, as Brianna had said, in addition to the video, the recording, these slides will be available. And so you'll be able to click on all these links and go look at these things. But I'll be showing you the repository after I cover more of these slides. Each function is documented in a separate markdown file. And but I do want to say these are not standard functions, right? These are kind of the functions I've created as my view on how to write Sentinel policies and how to write functions, and this is my particular approach. So they're not standard. On the other hand, it is, you certainly can use them, and you can expect to be supported if you are using them, just like you would be supported by HashiCorp support if you were using a framework that you created on your own, right? I mean, there's nothing stopping customers from creating a whole bunch of functions. They're effectively their own library of functions, and then if they have a problem using Sentinel, of course, they're entitled to support, assuming that they have a valid support contract and everything, right? So this is my particular take on how to go about doing this, but different, you might want to create your own functions that could be different. Okay, then the other new feature that we're going to be covering in these third generation, or that are used in the third generation policies and functions, are the new V2 versions of the Sentinel imports. These new V2 versions of 3 of the imports, tfplan, tfstate, and tfconfig, are aligned more closely with native Terraform 0.12 data structures. This makes the V2 imports easier to use in the V1 imports, and in particular, since the resource instances are stored in a single flat map in the tfplan import and the tfstate import, and that flat map spans across all Terraform modules and resource types, this makes it much easier to find all resource instances of a specific type or a sub-collection of those resource instances. So a lot of the code is easier. Now there is one catch, which is that the V2 imports are tied to Terraform 0.12, and that means they cannot be used with Terraform 0.11. So if you are still using Terraform 0.11, then I would recommend you use the second generation policies that are in the Terraform guides repository. So sorry. Okay, so the Sentinel imports, what do they actually do? The tfplan v2 imports gives data generated from Terraform plans specifically about the plan itself, right? What are the resources being planned? What are their attributes? The tfconfig import gives data about the Terraform configuration, meaning the Terraform code. Now, it's not 100% of everything you might have in the code, but it is a representation of that code, and it does include various expressions being used, to specify attributes of resources and things like that. So that can be useful in certain circumstances. Additionally, the tfconfig import has data about things that are not available in the tfplan or the tfstate imports, in particular providers, provisioners, module calls, maybe a few other things as well. And so there are certain situations, like if you want to restrict the AWS provider, as I mentioned, as possible, or other providers, you would use the tfconfig import. The tfstate import actually gives data about the current state of a workspace. And then finally, we have the tfrun import that provides metadata for Terraform runs and their workspaces, as well as cost estimate data. Now note, there is no V2 version of this. So if I temporarily just go over to, sorry, I need to move this. If I look at the documentation, we'll see down here defining policies, we have the 2 versions of tfconfig, 2 versions of tfplan, 2 versions of tfstate, and tfrun. And this is where you can come in and look at all these things, and get details about what the data is and how the data is organized. And there's all kinds of information there about using these imports. But with that, let me go back to the slides. So I do want to cover the evolution of the Sentinel policies and to give you a feeling for why they've been undergoing changes. Some of that has been driven by my and maybe other people having realized that we could do things better than was originally done. I would say that's true of the second generation policies. And then the third generation policies were primarily driven by these new features. So the first generation policies were written in late 2018, and they used the original Terraform Sentinel v1 imports. But they did have several shortcomings, including the following. Most of the policies did not print violation messages for resources that violated them. And they also stopped evaluating conditions as soon as a single resource instance violated them. So even if they had been printing violation warnings, what that meant is if you had 5 instances of a particular resource, like an S3 bucket, and the first one violated the policy, you maybe would get a printout saying, hey, this bucket violated the policy. You would fix it and then try to run your plan again. And then you would get a violation notice about the second one, right? And you'd have to fix it 5 times. And that's not what you want, right? People who, if you've done something wrong, you want to be told about everything you've done wrong up front so you can fix everything. then try again and hopefully succeed. So additionally, there were failures being generated when resources were being destroyed that violated certain conditions, and that didn't really make sense either. So in other words, I'm going to show you a policy that restricts EC2 instances to certain instance sizes, right, the types. Well, if you're destroying an EC2 instance, what do you care if it doesn't have a valid type, right? You're destroying it. In fact, you're probably bringing your overall Terraform configuration into compliance, with your policies, right? So there were things like that, and so we had to add checks in the second generation policies to test for that. And in the third generation policies, it's actually all much easier because the checks are easier to do. Another problem with the first generation policies, and this is the last one, is their use of the Sentinel output. The default Sentinel output was overly verbose. Or I should say the default Sentinel output is overly verbose. Well, it's overly verbose if you structure your policies in a certain way, in particular if you use multiple rules. Now, the documentation for Sentinel had actually advocated using multiple rules, and then your main rule would refer to the other rules, and that's what the documentation said. But unfortunately, that doesn't really lead to the best outcome. So in the second generation policies, which I kind of wrote most of, I did these in 2019, probably the first half, and I used the original, they still use the original Sentinel v1 imports, that's all that was available, but they made the following improvements. I offloaded most processing from rules into some common parameterized functions. Those functions were written in a way that caused all violations of all rules to be reported, so that was a big improvement. And they also printed out the full address of each resource instance that did violate a policy. So that's very important. Keep in mind, right, Terraform resources, when you look at a plan log or an apply log, the address of a resource in a module would be something like module.a.module.b.aws_instance. My Ubuntu, my web server, whatever, bracket 0, close bracket, right? So the Sentinel policies now could do the same thing in second generation and third generation policies. Now, additionally, by using a single main rule and by calling the functions before the main rule and effectively only using the main rule to evaluate a simple Boolean expression, that suppressed most of Sentinel's default verbose output. And so that made it easier for customers in other words, a lot of that output, I should explain, was aimed at the people writing the policies. It was almost like a form of debugging. But that's one audience, right? People who are running a policy could be the person who wrote the policy because they're running it to test it. But the other audience, and to me, the much more important audience, are the people who wrote Terraform code that violated the policy. And now they're seeing, a violation message or multiple violation messages, after they run their plan in the Terraform Cloud UI. Right. And to me, that's the most important audience because we need to be able to tell those people, and if you write Sentinel policies, want to be able to tell your Terraform developers, hey, these are the resources that violated the policy. And by the way, these are the things you can do to fix them. For instance, this resource, this AWS instance had instance type, M5.extra large, which is not in the allowed list. And then you give the list of allowed values, right? And now the person knows right away, okay, I need to pick an instance type in this list. Right, it's very easy. And they never have to look at the actual policy to go figure that out. So I think that's really important. Finally, they skipped resources that were being destroyed but not recreated. Okay, moving on to the third generation policies, and I want to be conscious of time here. The new third generation policies were written in the spring of 2020, this year, and they use the new V2 imports and Sentinel modules. So the main advantages of these policies are that because they're using the V2 imports and the Sentinel filter expression, that makes it easier for them to restrict policies to specific operations performed by Terraform. So in other words, only basically apply to resources that are being created or modified, which is usually what we want. Also, the common functions are defined in Sentinel modules, so they don't need to be pasted into the policies that use them. And most of the policies do not have any for loops or if-else conditionals. This makes the policies easier to understand and copy, especially by people who themselves are not developers and may never have really written any programs. And we also then another big advantage is these policies can evaluate the value of any attribute of any resource or data source. Oh, that's supposed to be an or. I knew I had seen this. I saw this at some point in this presentation or one of my presentations, and I actually wanted to fix it, and then I looked for it and I could not find it. Let me go to full screen again. So now it's fixed. So, sorry. So, but I knew I'd seen someplace an of instead of an or, and this is where it was. They can evaluate the value of any attribute of any resource or data source, even those that are deeply nested. And this is something that the second generation functions did not do. And I actually could have done this, but I didn't in the second generation functions because those functions were pasted into the body of the policies, and I just didn't want all that complexity in there. It would have been too confusing. But now, because these functions are kind of hidden away, like this particular function that does this is called by other functions that are called by the policies. Now I could add that capability. Now, again, as I mentioned, the V2 imports only support Terraform 0.12, and then they'll clearly support Terraform 0.13 as well, which is going to be in beta soon. So you cannot use these with these third generation policies. You cannot use with Terraform 0.11. Okay, so I want to review a few of these policies. I'm going to review 4 different policies, and I'm not going to do that here, but I included the links to them. I'm going to do that in GitHub after another sip of water here. I'm so sorry. Okay, so let's look here at the policy. So first of all, here you can see, the Terraform guides. This is a HashiCorp Terraform-guides, and I'm looking at governance, and then we see the list of all the different 3 generations. I'll start with the second generation policy. We can see that policies are organized by cloud, and also we have cloud agnostic policies, and we have common functions. So we currently do have policies for both second generation and third generation for AWS, Azure, Google, and VMware. So let me go into the AWS directory and pull up this policy. This is a policy that's restricting EC2 instance types. And I could have picked, I have similar policies for Azure and Google. I'm just happy, I'm using the EC2 one here. So we see here that this thing starts out with a few import statements. That's good. Then I have a find resources from plan function. But I had to paste it into the body of this policy because there was no way for the policy to call the function from a different file. So, but that's all very generic code, right? There's nothing in this function which goes from there down to here. There's nothing in here that's, specific to this policy. That's boilerplate, right? That's a common function. That common function, by the way, takes the type of resource, and that's, what it uses to then filter. Notice, by the way, the 3 for loops, 1, 2, 3, that the function was more complicated because the V1 import organized resources by module, then by resource name, and then by instance. Okay, now I have a second function, and don't worry if you understand this code or not. It's more, I'm pointing out the degree and the amount of coding here. I have a validate attribute and list function, which takes in the type, the resource type, the attribute that you're going to restrict, and a list of allowed values. Here I'm calling the first function, passing in type, right? So whatever type was passed into this function gets passed to the first function. We can see I'm doing some complicated checking and conditional stuff and et cetera. Down here, this is the part of the policy that is actually unique to this policy, right? This is where I have an allowed list of EC2 instance types. I'm calling the second function, and I'm passing in, I'm trying to highlight here, sorry, AWS instance as the type of resource, instance type as the attribute, and allowed types, which is the list. And then I have my main rule, which just evaluates that Boolean value, which was returned by that function, right? So really, this part of the policy here is the part that's specific here. Let's compare that second generation policy to this third generation policy. It's doing the same exact thing. We have, I have an import, although it's a different import. I'm importing my TF plan functions module, right? So I'm importing that Sentinel module, so I don't have to paste the functions in. I have my list of 3 allowed instance types. I'm calling a function here called find resources, which again, I'm just calling it as opposed to copying it. And then I have a second, a function called filter attribute not list. Very similar, right? I mean, here I was doing, I wasn't doing a filter, I called it validate. I kind of changed I decided to, instead of having validate functions, I have filter functions. It's not a pure filter because what it actually does is these filter functions return 2 different maps. They return a subset of the original collection, but then they also return a map, which is a map of violation messages. And this is where this 4th parameter comes in, which can be set to true or false. if you set this to true, it will automatically print everything. It will print the violation messages, but there are some cases, as we'll see in a minute, where it's better to delay the printing of the violation messages. So in that case, you would set this to false and then call another function to print the violation messages. In any case, here what I'm checking is I'm checking the length of the messages map that was returned by the second function. In any case, again, don't worry too much about all the details. The point is we have 23 lines of code here compared to 102 lines of code, right? It's a lot shorter. I should mention, by the way, all of this is documented. I kind of wrote a blog post about this. This is all in this blog post that covers all this material in great detail. So that's another way you can kind of, if you want to go through this afterwards. Some people prefer to learn things by, watching, video and listening to people talk about things. Other people prefer to read text. So I'm kind of more in the latter category. So do keep in mind this blog post. The link to this I'll have at the very end. Okay, so we had the second generation, then third generation was much shorter. That was the first prototypical policy. What I'd like to do now is let me show you a few other policies that are a little more complex. So first of all, let's look at this VMware policy that restricts VM CPU and memory. The only real difference here is that I have two different conditions that I want to apply. First of all, I want to limit the CPU and the memory limits of a VMware VM. So I'm calling a find function just like before, but I'm specifying a different resource type. And then I'm doing two filters. I'm using a different filter function. I'm calling filter attribute greater than value. In other words, I'm looking for those VMs where the num CPUs attribute is higher than max CPUs. So this will give me a certain set of VMs that violate that first condition. Then I have a second, I call the same function a second time against the first collection, against this collection of all VMs. And here I'm checking the memory attribute and I'm comparing it to the max memory limit, of 8 gig, right? And in both cases, I'm going to print my violation messages. And so then here I'm basically saying, hey, I want my validated Boolean variable is set to, I want the length of this thing to be 0, right? In other words, there should be no messages for high CPU VMs, and there should be no violations of the high memory condition. And so I'm basing my main rule is just testing validated. And by the way, what I could do at this point maybe is I'll just show you what that looks like. I'll actually show you here, like for the AWS policy. This is with the CLI. I'll show you later in the UI, in the Terraform UI. So let me do this. Let's do ls, and I can do Sentinel. Sorry, I'm not spelling that right. And let's do, I want to just get this guy, so we'll copy that, and I'll say verbose. So notice what we're getting here. This is running this in the CLI. I have two test cases. I have a failed test case and a pass test case. I'm not going to explain the whole thing with all the tests. Sorry, I should probably make this bigger for you guys. Hold on one second. That should be good. All right, so you can see this gave these nice messages I was talking about where it's saying things like aws.ubuntu _0 has instance type with value t2.extra large that is not in the allowed list, which consists of T2 small, medium, and large, right? And then we see a second violation and a third violation. And notice in this case, it's giving us the module.nested.awsinstance.ubuntu, right? So that's one example. And then what we can do is we can switch over to the VMware directory, ls, and I could say Sentinel. Sorry, I don't know why I can't type this. Sentinel test run equals, and we'll just do the first one. So actually, I can just do memory. This does partial matching. Run equals memory verbose. And here we're seeing, we look at some of the failures, like this one saying vSphere virtual machine VM has num CPUs with value 8 that's greater than 4. And it's saying vSphere virtual machine, blah, 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 has memory with value 16 gig that's greater than 8 gig, right? And then here we have other use cases where we're getting similar warning messages. So those are the kind of warning messages being generated by the functions behind the scene. Okay, so having shown you this one, let me move on to the third one, which is this VM disk size. And this is only has a single condition, but it's a little more complicated in that resources in Terraform can have nested blocks. and those blocks can even have nested blocks, and this is where things become a little more complex. In this case, we're restricting the disk being attached to a VM that's being created in VMware. So after, what I have to do is get my list of all VMs with my find resources function, but then I do have to use some conditional logic. I have to iterate over all those VMs and then find all the disks of each VM. And once I find the disk, then I can apply a filter to the disks, right? And I compare the size of the disk to the max disk size, which is 100 gigabytes. And this is a case where I am using false for the in this filter function. I'm using false because you'll see I'll show you in a minute. But fundamentally to make the messages that are printed clearer, because what I then do is I check the length of the messages, see if there are any violations. If so, I set disvalidated equal false. And then I print a generic message for this VM. I print out, notice that I'm including the address of the virtual machine and actually indicating, I'm saying that it has at least one disk that's greater than max disk size. But then what I'm doing is I'm calling this print violations messages, in which I preface the messages with disk. Let's see what that actually looks like. So I'll clear, do an ls, and then I can do like this, go back and do disk. Notice here what we get is we get that first message, the one the one I had in the code that says, hey, this virtual machine has at least one disk that's too big. And then I'm printing out these messages, right? Disk 0 has size with value 120 that's greater than 100. Disk 1 has size with value 160 that's greater than 100. So I think this explains why I have this option of delaying the printing of the messages. This disk came from, the disk that's in the last, second, and third messages came from this, okay? If I hadn't done that, if I had simply printed the messages, if I'd used true, this is what I would have gotten. I wouldn't have had the first line. I would have just seen 0 has disk size with value 120. Well, what does that mean? What's 0? You wouldn't know what that is, or the person with who wrote the Terraform code wouldn't know what that was, because disks of a VM are just like indexed. The first one is 0, the second one is 1, etc. Right? And the second message then would have just been this, right? And that would not have been clear either. So that's why we have this ability to delay the messages. Okay, finally, there's one more, which is oh, sorry. I might have skipped the second one, but maybe that might be enough. Anyways, let's see. Publishers of current VMs. Let's take a look at this one. So I'll go to third generation. I did do them in the right order. This one is restrict publishers of current VMs. This one is, first of all, using the tf-state import. So it's using my tf-state functions. And I have this allowed publishers equals Red Hat and Canonical. So, I only want to do those. This is the point of this is to illustrate how you can evaluate nested attributes. If we were to look at the Azure virtual machine, the Azure RM virtual machine resource, you would see that the publisher is inside a storage image reference block. And so what this part is saying here is I'm saying that I want to evaluate the publisher attribute of the zeroth instance, and there's only going to be one, of the 0th instance of the storage image reference block. And so this is that gets passed on to my evaluate attribute function, which is able to process that. So this is something kind of unique to my framework, but this is why I showed this one as well. So I'm not going to I won't show, well, I can show you the results for it really quickly. So if we just, keep in mind, I'm doing a large part of the demo up front here. So Azure, ls, and I can do Sentinel, and we'll do current, and we get a message like this, right? We get Azure Virtual Machine Demo has this guy, this attribute with value Microsoft Windows Server that is not in the allowed list of Red Hat and Canonical. Okay, so that's what we get for that one. Okay, with that, let me go back to the slides. I am conscious I want to leave time for Q&A. So I've already explained some of these functions, so I'll try to go faster through this. I'll indicate that there's two groups of functions in the TF plan and TF state modules, and I'm not going to cover the functions in the other ones. There are find functions, there are filter functions, there's this evaluate attribute function that all the filter functions call, And this is like the real important function because this is the one that ultimately evaluates deeply nested attributes. And how it does that, by the way, is by calling itself recursively. So for those who have done programming, in some languages, a function can call itself recursively, and Sentinel supports that. And then finally, I have the toString and the print violation functions. The toString function is used to build up the messages, so I can convert any Sentinel object into a string. And the print violation function is the one we saw used in the third policy, if you want to print your violations after you do your filtering. And there's also, by the way, a Sentinel module that has some AWS specific functions. So with that, I basically just showed you how to test the policies with the Sentinel CLI. What I didn't show you is, this is the process, right? And the blog post gives you this process. You would download the Sentinel CLI, you unzip this zip file and place the Sentinel binary in your path. You should probably fork the Terraform guides repository and clone your fork to your local machine. Although if you wanted to just clone it directly, you could for purposes of using the CLI. Navigate to one of the cloud directories. Like you saw, I was navigating to the different directories, and then run Sentinel test to test all policies, right? That would look like this. Sentinel test, and it does everything without the verbose output. You could also do this with verbose, and then you get all your violation messages. And then, as we say, or you can do -run equals a partial policy name with -verbose in order to test individual policies. This is what a test case looks like. I didn't show you any of the test cases, but you basically have references to something called, from Terraform plans that you run in Terraform Cloud and Enterprise, you can generate these things called mocks, and then you can edit them. So to use the CLI to test Terraform Sentinel policies, you need to have some mocks that you generate, and then you can copy the mocks and edit them. So you have pass mocks, fail mocks. So if you have a test case, like this would be my pass test case, it's referring to my mock TF plan pass Sentinel mock file. And then you can reference any modules that you want to use. So here I'm referencing my TF plan functions Sentinel module. And then you have a condition. You're saying, hey, the main rule has to result in true. So that's what a test case looks like. And then that's essentially, and then you use it the way I showed you. If you want to deploy policies in TFC and TFE, Terraform Cloud and Enterprise, basically you need to then, you end up creating a policy set. You register, you put that in a GitHub, Bitbucket, GitLab repository, or one of the other supported VCS systems, and then you essentially register a policy set, in your organization. You can add any parameters that your policies might need, and you can add references to any Sentinel modules. These are all done. The references to Sentinel modules and references to the policies would be done in the actual sentinel.hcl file. There's this thing called this policy. Here we go. We have the Sentinel policy set. So you have a reference to your TF plan functions, just like we had before, and you have references to your policies. You don't have to specify the source currently if it's just in the local directory, but it's probably a good idea to start. One day you will have to do that. So if you can just specify the source and the enforcement level of the policies. So I don't know if this slide said it. It probably did not, but the file, your policy set configuration file has to be called sentinel.hcl. Okay, so I will now, having covered all the slides, I'll do the rest of the demo, and then we should have 15 minutes left for questions. So the only part of the demo that I still want to do is the part where I would do this in run. So I have some policy sets here. I have one Terraform guides AWS. We can see here is pointing to the governance / third generation / AWS directory of the Terraform guides repository. Here we can see this is pointing to HashiCorp Terraform guides. We even can see the most recent Git. I could click on that and jump over to that and see it. And I'm enforcing this on all workspaces, and I don't have any Sentinel parameters. So that's one policy set. And then this policy set is Terraform guides cloud agnostic. It's pointing to the same repository, Terraform guides, but then if we look at the extra options, it's using the path governance third generation cloud agnostic. And if I just come back here, we can see where these, for instance, the cloud agnostic, we can see the policy set, sentinel.hcl file is sitting here. We see the references to the various modules I'm using and the references to all the policies and their enforcement levels. Now I have these set up all to use the advisory enforcement level. So those are the two policy sets that will be applicable to what I'm going to do. I'm in a workspace that provisions an EC2 instance, and I'm going to go ahead and queue that demo for webinar. So the plan will take a minute or two to run. Here we go, and this won't take very long. And then after that, we'll see the policy checks. While we're doing that, what I will do is I'll come back here and just show some useful links. Feel free if you want to take photograph of this, you can capture some of these. A few of the links are more complicated. I guess I could have spelled out the full, it's kind of a complicated blog link. But this is the blog is a Medium blog. And what I've done for that link is I've given you guys the version of this post that does not require you. It's called a friend link, right? The friend link in Medium means that if you have, if you're a Medium subscriber or whatever, you won't be limited and it won't count against your quota in Medium. So that's why it's a fairly long link, and that's why it's like this. And then this is a link I've written a Sentinel in Terraform V2 workshop that has, this is a link to about 100 slides, more than 100 slides probably, that walk you through how to write and test Sentinel policies for Terraform. And that includes a hand-on instruct track that teaches you how to write and test your policies. And so that's the hands-on track that's actually over here, and that's something that you can run through on your own. What this track does, it's all self-contained. You run this through a browser, that's all you need. It uses the Sentinel CLI and some mocks that I generated for these different exercises, which are from a white paper I wrote a long time ago. And essentially the policies, I've essentially, for each exercise, the policy is mostly already written with a few placeholders that you have to fill in. And so, your job here is basically, as you go through this, is for each exercise is to replace the placeholders with the suitable values. And there, you can get hints when you're going through this. There's a check button you can click. You can get extra hints. But this is pretty useful if you want to learn how to write and test Sentinel policies. And these do, over the course of these there's 5 exercises plus an extra credit policy. These do use all 4 of the Terraform, the Terraform Sentinel imports, the TF plan, state, config, and TF run. Okay, so with that, our plan should be done. Here we can see the plan is done, and I can come down here and look at the policy checks. And notice here, we see which things they're coming from. We can see Terraform guides AWS. We see a whole bunch of AWS policies. I have one that failed here about the instance type, and I have a few other that failed from the that cloud agnostic policies, right? I have prevent non-root providers failed because I had providers in a non-root module. I also was creating resources in my root module, which means that I violated that one, and I had some variables that don't have descriptions. Now we can see this full screen like this. We can see this is from the AWS one first. So where is this? Sorry, I have to scroll up. And this will be, I'll very quickly get to answer questions starting in 1 minute. Here we can see the error messages, just like what we saw in the CLI, right? We see this messages about AWS instances not having values allowed. I can't seem to, there we go, I was trying to highlight. We also then, if we scroll down, we'll see some of the other ones that had errors. I have to get down to the next policy set. Okay, here we go. Providers are only allowed in the root module. Provider module.nested : AWS was defined in module.nested, right? So that's giving a warning. And then we have another one, this particular organization's required, but no value was provided. Oh, that's like actually a hard error. Oh, that's interesting. Oh, well, here, this is something about variables that didn't have descriptions. I'll have to look at this one later. Which one is that? That's require all resources from PMR. Okay. Oh, I think maybe because that's interesting. Okay, I'll have to look into that. Okay. Anyways, so with that, I think I am done. Let me just see if I had anything else here. No, that was it. So these are the different links you have. Feel free to capture a screenshot of that for the first 3, or you can capture these later once this is posted. So with that, we have about 10 minutes left to answer questions. I apologize I didn't go faster. I'll take a look at the chat. Or Brianna, did you want to start reading some questions to me?
Yep, I have the questions ready.
Great.
Okay, so first question is, can Sentinel only be used in TFC and TFE, or can it be used in open source as well?
It's not really intended for being used in open source, and these imports technically are difficult to use in open source because you need those mocks that I talked about, and you can only generate those mocks from Terraform Cloud and Terraform Enterprise. It is possible, kind of to use Sentinel with open source because the Sentinel CLI itself is not, that's something that people can just download and use. And you could, in theory, there's ways to kind of do it. There's ways to kind of run a certain Terraform command that'll generate a JSON file. Actually, you can see this right here. This is saying what this does. The Terraform show-JSON, you could run that command after running a Terraform plan and generating, a plan from that. And then you could, actually write a policy that would actually look at that JSON document itself. You wouldn't be using these imports. And so you wouldn't be able to, like my third generation functions as written would not work directly. You would have to do some modifications maybe to make that work. But primarily, most people using Sentinel are using it with Terraform Cloud and Terraform Enterprise.
Okay, great. So will the Sentinel policy be validated when destroying a plan?
Oh, when doing a destroy. So
Yes.
Sentinel policies are checked. This depends on what you do. Let's take a look at if we actually look here, I'm on the right screen as it turns out, we have this information about resource changes. And if we look at resource changes, part of a change representation includes the actions that are being done, as well as the state before, after, and then also after unknown if you have computed values. So if we look at the actions, you have create, read, update, and delete, and no op. So if we were to look at my functions, you'll see that what I do in my functions, some of the common functions, let's take a look at TF plan. I actually in this, I'm sorry, too far down. If I look here at the TF plan function Sentinel file, if we look at the very first function, I'm actually intentionally here only, when I call the function find resources, which I used in all 4 of the policies I showed you, I'm only looking for the resource change, the change.action. So RC represents a resource change. I'm looking for change.actions to contain create or to contain update. Because if it doesn't have one of those, then I'm basically assuming that it's being destroyed or something else. In other words, it's not, if it doesn't have, create or update, if it's only being read, I don't care, right? There's nothing to restrict. It's a pre-existing thing. Now, for data sources, that's different. I do look at that, but yes, you could. There are some policies that behave a little different. Like if we look at the whole list of all the policies here, there are some policies in the cloud agnostic in particular that look at like prevent destruction of blacklisted resources. So this is one that is being applied. It's using TF plan, but it's actually doing a find resources being destroyed. I have a specific function to look for resources being destroyed, right? So that is certainly possible. Next question.
Great. So is there a way to report on Sentinel policies across workspaces, mainly to identify if one policy is causing false positives and generate metrics?
So we don't have any kind of built-in reporting. What you could in theory do is the following. You could in theory, but this is heavy. It's like, the fundamental answer is no. I mean, there is this TF state import, and maybe I'm going to answer a different question, which is that sometimes people will say, how can I check existing resources? If you're only running the Sentinel policies after you do a plan, how can I go check if there are existing resources? Maybe that weren't even, now I should say that Sentinel in Terraform can only look at resources that are part of the state of a workspace, part of the state of a workspace. But you might ask, well, what if I want to make sure that nobody has gone and changed something, using the cloud, some cloud console or an API or a CLI? How can I do that? The answer is that you could write some kind of script that would essentially iterate over all your workspaces, right? If we look here at all the workspaces, you could iterate over all your workspaces using, we have a Terraform API, Terraform Cloud API. You could iterate over all the workspaces and then run something called a speculative plan against each workspace. A speculative plan cannot actually be applied, and it doesn't show up in the history of the runs for a workspace, right? When I look at a workspace, like this one, the one we were on before, I see the run of the histories, but the speculative plans will not show up there. And so what you do is you run these speculative plans, and then that anytime you run a plan, including a speculative plan, that will cause the Sentinel policy checks to be done, and then you would get output from all of those. And so you could then at that point, your script would essentially collect all the violations across all your workspaces that were currently any current violations. In other words, this would tell you across all your workspaces if there are any resources not in compliance with any of your policies. Now, to do that, you would have to write separate policies using the TF state import. But one of the reasons, in terms of the structuring of my functions, the way I've built the functions, if we were to look at the document, if you went and looked at the documentation of the TF plan and let's say the TF state functions, you're going to see that the documentation, the functions, the list of functions are identical. So it's very easy actually, and I'll show you, maybe I can show you this way. If we go back and look at the AWS policies, I had the policy that I showed you that was this one that was restricting EC2 instances. I also have one that's actually very similar that restricts current EC2 instances. And this policy is almost identical. The only thing is it's importing this TF state functions, and then it's using state instead of plan, state instead of plan. Everything else is the same, right? So you effectively would end up having pairs of policies, one for plan and one for state. And then you could do that kind of reporting that the person had asked about effectively by running these plans, periodically, like once a day or once a week or whatever you wanted to do. Okay. Next question.
Is it possible to use TFC's workspace variables as Sentinel parameters, for example, to define the maximum cost of the current workspace in which Sentinel is executed?
You couldn't use those as parameters because parameters you could reference them and they could maybe influence the policy, but actually I need to double check that. Here's the issue. The issue is that when we're looking at a policy set, the parameters are defined here in the policy set. So the parameters have to be set with basically static strings or values here. You can't refer to Terraform. In other words, here, there's no mechanism, at least currently, to say, hey, I want to refer to Terraform, var, so there's no special mechanism for that. Whatever your name you give it, you're going to give some value. Like usually these are cloud credentials, or it could be an API token for talking to TFE itself. Now, that being said, if we look at the TF-run import, I'm trying to see if it has reference to it does have reference to variables, but I need to check what data it has. It may not have enough data to be useful. No, it doesn't, because it just gives their category and whether they're sensitive or not. So you would not, if you were trying to actually, based on the value of a variable, do different processing, you wouldn't do it from here. You could, however, do it from, I believe, from the TF plan import, because the TF plan import does include variables, which is a map of keys, and we'd have to scroll down quite a bit to find, oh, here we go, variables. This would have the actual values, this would have the values of the variables. So this would, in other words, you could have a policy that would use the TF plan import, check a specific variable and check what the value is, and then do some kind of processing, conditional processing based on the value of that variable. A similar thing, by the way, that's done is if I go back to the TF-run import, people will ask, and yesterday I was speaking with a customer who wanted to know, how can I make a policy behave differently for, let's say, dev, QA, and production? Or the real question was, I want to have policies that are different for dev, QA, and production. Do I need to create a separate policy for, do I need to create 3 versions of the same policy with different, limits or whatever? And the answer is not necessarily, because here the TF-run import does have the workspace name, and it also has the name of the organization. So depending on whether, if you're using 3 different organizations, let's say for dev, QA, and prod, then you could do conditional processing based on the organization name. Or let's say if you're using a single organization, but you name your workspaces, let's say to end in -dev, -QA, -prod, then you could do conditional processing based on the workspace name, extracted from the TF-run import. And so that would let you use a single policy to behave differently in different contexts. One more point I want to make, by the way, about reusability of policy sets. Keep in mind that a policy set, both of the policy sets I had were pointing to, Sentinel HCL files inside this particular repository. But if I wanted to use the same policy set, let's say that AWS, this one, I could define the same AWS, I could register that policy set from here into multiple organizations, either within a single, Terraform Enterprise or Terraform Cloud, deployment, or across multiple TFE deployments. So keep that in mind also. You get good reusability of the policy sets. Okay, next quick question, if any. I know we're at the end of the hour, but I'm certainly happy to go on if there's still people. We have more
Yeah, so we
questions.
do know we're going over, but we do have a few more questions. So, do Sentinel modules support importing lists of data in addition to functions? For example, could they be used to store a large list of items that will be referenced by multiple functions?
They could, yes, because a Sentinel module can define variables, and a list of data, any kind of data, would just be represented as some kind of list or some kind of map. So yeah, that could absolutely be included in the. Now, as to referring to those lists, you might not be able to refer to them from the policy directly. You might have to refer to that data from the functions. So it would be the functions inside the module probably referring and accessing that data. But yeah, you could do that.
Okay, awesome. When writing Sentinel code, is there anything for testing similar to TerraTest?
I'm not super familiar with TerraTest. I've heard of it, but I would say the Sentinel CLI, what I showed you before, right? That's what this is testing your Sentinel code. Now, if the question is more like, well, I talked about this of actually testing or your policies being validated, passing or failing. If you're thinking, maybe the person was thinking about doing syntax checking and things like that. And then the answer is yes, because if there are bugs, you're going to get different warnings. So for instance here, if I were to edit something like this, and I'm probably going to regret doing this, right? If I edit this, and let's say I introduce a bug, find resources, I'll do this. And now I can, where am I? Sentinel test dash run equals size. No, not size. I want to do, oh, this is Azure anyways. Yeah, size should do it. Notice here I'm getting this error. Error restrict VM size Sentinel 13.15, attempting to call non-function, and this is referring, it's not saying the name of the function, but we can see it's line 13. And if I were to VI the file again and go to line 13, that's where I had the extra S that I added, right? So you will get syntax error checking when you're using the CLI. And you would also get syntax error checking when running in Terraform Cloud or Terraform Enterprise, but obviously you want to get rid of your syntax errors with the CLI first. Okay, I'm sorry, next question.
Okay, cool. We're just going to go through 2 more questions and then we'll end it. So is it possible to apply Sentinel to make some data validation when we run a data pipeline?
Sentinel can do data validation. You could, there's a string, so part of the Sentinel language includes a string. There are 2 things. There's the matches operator. So if you want to use regex, you could check, some string against a regex expression and make sure it validates that. That's under something called the matches operator. And then we also have some common built-in standard imports. So we have the strings import. So if you want to check the prefix of a string or the suffix of a string, you can do some checking against the strings. The actual function I mentioned should be, it's not a function technically, it's a built-in operator. But there is a matches operator. So yes, you could effectively do validation with Sentinel. But the one thing I want to mention, what Sentinel does not do, Sentinel does not validate, for instance, let's say you pass in a KMS key. So an Amazon, KMS key. Sentinel does not check whether that KMS key is actually a valid key that exists. In other words, Sentinel could be used to check the form. Does it have the right length? Does it have the right pattern? Wherever the hyphens are supposed to be, it could check the form of the key, but it's not going to go talk. Sentinel does not talk to the various cloud, APIs to say, hey, does this key really exist? Now that's okay though, because Terraform does do that, or I should say the Terraform providers do that, right? When you do your plan and then later your apply, the apply, is going to use the AWS provider in that case, and the AWS provider is going to talk to the AWS, API, and that API at some point is going to be checking, is that a valid a KMS key, things like that. So those things will be checked by Terraform, but not by Sentinel. All right,
okay.
Next question. Sorry.
Last question. So I see AWS, Azure, and VMware. Do you also support Oracle Cloud?
Oracle is supported by Terraform itself, right? There's an Oracle provider. We could look at the Terraform docs, and find, like if we went and looked at providers. And so Terraform, Oracle Cloud is certainly, there's, an Oracle public cloud provider, and you can see the various resources for it. Sentinel could certainly be used against this also. I just have not created any Sentinel policies, any example policies for it. But absolutely, Sentinel can be used to, if I go back a second, Sentinel can be used to restrict any resource or data source, or let me rephrase that. It can restrict any attribute, or parameter of any resource or any data source from any provider, whether it's whether it's one of these official providers, or even if it's just one of these community. We also have the community providers as well, right? Any provider. So yeah, Sentinel can be used against all these different things. It's very broad in its focus.
Okay, thank you, Roger. So thank you for your expertise on all the questions. Sorry to everyone for going a bit over, but as I mentioned at the beginning, this Hangout was recorded and will be made available with the slides after post-processing. I will send an email out to all of you. If you like what you heard today and want to start exploring Terraform more, I encourage you to check out our Learn site at learn.hashicorp.com. Additionally, we will be hosting a Terraform workshop on June 11th, so please be sure to check out our events page at events.hashicorp.com and check out all of our upcoming workshops. We do them across all of our tools. So I hope you all enjoy.
Sorry, Brianna, I just posted the link to the Medium blog, the Friends link, into the chat. So if anybody doesn't want to wait for the recording and they would like to read that blog post, they can click on the link in the chat.
Perfect, thank you. So I hope you all enjoyed today's Hangout and have a better understanding of the new Sentinel features in Terraform Cloud. So thanks for joining us today, and a big thank you to Roger for his time.
Thank you,
Have
Brianna.
a great rest of the day. Thank you, everyone.
Bye-bye.